Hi, everybody. I'm going to go through these. We started this worksheet in class and we did this middle problem. I'm going to kind of just talk through the rest of these so that it makes sense. I also posted the key if you read my email in week 1. But this first problem up here, it says a cellular data plan has a fixed monthly cost and additional charge per gigabyte of data used. If a customer uses up to 3 gigabytes of data during the month, the cost of the plan is $24.25. If the customer uses up to 11 gigabytes of data during the month, the cost of the plan increases to $46.25 for the month. Find a linear equation that models the monthly cost C. When they say the word linear equation or linear model, we are going to come up with an equation, a formula that is of the form y equals mx plus b. Now, our y might be called something else like what it represents. So in this instance, it will be. We're going to call it c eventually. And our x could be x, or they could label that some other thing. They could call it g for gigabytes if they wanted to, but they told us in this problem to use x. So a couple of things I want to do in this example. One is make sure you understand mathematically how to do this. And 2 is very specific to this homework system. I don't want you to frustrate when you have to enter the answers. So if you entered it as y equals something and it tells you you're wrong, but you did the concepts correct, and they just wanted you to change a variable, I wanted to address that so that it's not a big thing. So whenever they say linear, we are going to be modeling off of something like this. And when they use the word fixed monthly cost or a base fee, that is your y-intercept. See, that is not changing with the value of x. It's always the same. It's fixed. So that is what that is indicating. So it says a cellular data plan has a fixed monthly cost. We're going to figure what that is, an additional charge of gigabyte data use. If a customer uses up to 3 gigabytes during the month, the cost is this. So I see two things happening. I see an amount of data usage in gigabytes and the cost. So if I have an X and a Y coordinate, I'm going to say the cost is dependent on how much data I use. So I'm going to let X represent the number of gigabyte data used in the month. I'm going to let Y represent the cost per month. That's in money. Okay, so that's what my variables represent. So right now what I'm doing is not trying to answer these little questions. I'm thinking about what this problem is doing so I can come up with something. So when I read this, it says if a customer uses 3 gigabytes of data, it costs $24.25. There's 1 point, XY. If the customer uses up to 11 gigabytes of data, the cost is $46.25. And so what I see is I have 2 months. So if we think back to the exercises that we learned about just plain how to write the equation of a line, if you have 2 points, we're in business because we have 2 points. So if we can figure out the slope, and we can, that's the change in y over the change in x. Over the change in x, which is y2 minus y1 over x2 minus x1. So we're going to say the slope is 46.25 minus 24.25, y2 minus y1 over 11 minus 3, x2 minus x1. And when we do that, and I'm going to use my calculator, I'm going to say 46.25 minus 24.25, I get 22 over 8. And 22 divided by 8 gives me 2.75. So 2.75 is the slope. Now to write the equation of the line, I need to say y minus y1 is m times x minus x1. That's our little point slope formula. I'm going to say y minus, pick either one of these points. I'll choose this one. 24.25 is equal to m, what we just calculated, 2.75 times x minus 3. Now, this is our equation. Okay, about at this point, I'm going to start thinking about what do they want me to put in here. So they do want this equation, but they don't want it to look like this. They want it to be cleaned up. And what I mean by cleaned up is I'm going to distribute this, and I'm going to solve for y and add this to the other side. In addition, before I put my answer in, I'm going to look at how the variables they wanted me to say. And so they also want not a y, but what y represents in this problem. They said, call it c. So first, let me solve this equation. So when I distribute, I'm going to get 2.75x minus 2.75 times -3, which is -8.25. And then I'm going to add this to the other side, plus 24.25. So that's going to end up being 2.75x plus, let's see, -8.25 plus 24.25 is 16. So instead of calling this y, I'm going to call this c. And this will get you a check if you do this in your homework. All right. And then it wants you to talk about what just happened. So I'm going to talk about it, and then I'm going to tell you how to answer these questions. Interpret the slope of the equation. Well, here is our slope. Our slope is 2.75. Okay, that's a number. What does that mean? Well, we ought to think about it. A slope is always a rate of change. It's the change in the y over the change in the x, and the y represents the cost. So it's the change in the monthly cost per, what did x represent? Per gigabyte. So if you are like, what does the slope represent in each little problem? Think about what is y? That's money. What is x? That's gigabytes. And that's going to help you interpret this. So what they want us to, there's a menu of things to select, but what's going to help you select this is what we're going to say is the cost per month is what they want us to put here, cost per month. And the reason I'm telling you the answer is because even when I did, I was like, what do they want? And they want to say is increasing. And the reason we say it's increasing is simply because the slope was a positive number. Increasing by, and then by how much? We're going to say by 2.75. And then what were we going to select? They give you dollars per gigabyte is what we'll say there. All right. Then it says interpret y, the intercept of the equation. And we sort of already talked about that is going to be the y-intercept is the b, and that's the fixed monthly cost. The fixed monthly cost is, and how much is it? What's the value? Well, we said our y-intercept is 16. 16, and that's just dollars. That's the fixed fee. That's what you put there. And then part 4, use your equation to find the monthly cost of 20 gigabytes. What will we do there? Well, we have C equals to 2.75x plus 16. But many times we'll write this as C of x. It's a function of x. And so what this means is x represents the number of gigabytes. If we simply put 20 in for x, C of 20, we can get our answer. So we'll take 2.75 times 20 plus 16. And that will give us just $71. And so you're just supposed to put 71 in here. All right, so that's a way to interpret a math problem, that you keep for life. Very specific is how they want you to answer this in your math system. That's the second part. All right, we did this one in class. I'm just going to go through it pretty quickly. I'm not going to, because we explained it in class. But it says in 2016, the owl population in the park was estimated to be 442. By 2028, the population is estimated to be 292. Assume the population changes linearly. So this right here says, oh, they want us to write something like this. That is what this can be modeled off of. So when it says find a formula, they mean write this for the owl population P. When they say that, they say don't write Y when you put in your answer, write in P equals 2. All right. So what did they tell us? Oh, and then they said let T be the number of years since 2004. So that is called normalizing your data. So initially, when I'm getting to know this problem, when I read it, I'm just going to write down what comes to me. And so what comes to me is in 2016, there's 442 owls. And then by 2028, there's 292. Just I'm looking at that, and as time goes on, there are less owls. It's decreasing. I'm expecting a negative slope here. Okay, now I'm going to go ahead and take care of this. They said normalize your data. So T is going to be my X. So this is time. And so the two variables, instead of it being an X and a Y, are going to be T and P. That's what we're going to call them. T for time since 2000, the year since 2004, and P is the population. So how I'm going to do that is I'm going to take 2016 minus 4, which gives me, is that 12? Oh gosh, I'm having a terrible subtraction day. Yeah, it's 12. So when I write down 12, the population is 442. That really means in 2016. And then if I take 2028 minus 2004, I get 24. So when I write down 24, that's representing 2028. There's 292. We will calculate our slope, change in y. So I'm going to start here. 292 minus 442 over 24 minus 12. I get a 12 down here, and I get a negative number up here, which I was expecting because, why was I expecting that? Because I could just observe that it was decreasing. So 292 minus 442 gives me negative 150. If I divide by 12, my slope is negative 12.5. All right. Then I'm going to write y minus y1 is m times x minus x1, and then I'm going to solve for y. Same thing as up there. So y minus 442 is negative 12.5 times x minus 12. That's what was with that point. So y is negative 12.5x plus 12.5 times 12, 150. And then I add 442. So it ends up being negative 12.5, but I'm going to call it T instead of X, plus 592. And instead of calling it Y, I'm going to call it P. And that's what we can put right there. Then what does your model predict the owl population to be in 2033? Let's just think about it before we put that in. Less owls, because with each year it's decreasing, right? So we are expecting a smaller number than 292 because it's later. All right, so what do we put in for T? Well, since it's normalized, we take 2033 minus 2004, and that says, oh, let T be 29 since we normalize it. So put in 29 for T right here. And when you do that, you'll get 229. All right. Lastly, we did talk about this briefly. I wanted you to have the setup for this. This is the third one. It says you're choosing. Oh, no, this is not. I thought this was. Oh, I didn't even see this one. All right, let's do this one. You are choosing between two different window washing companies. The first charges $11 per window. The second charges a base fee of $44 plus $7 per window. How many windows would you need to have for the second company to be preferable? All right, so here's the two companies. That company A, how much does it charge? $11 per window. Let's let X represent the number of windows you need cleaned. All right. So how would I represent the costs? Well, $11 times the number of windows. That's the cost. This is the cost. And I wrote that instead of C equals 11X, I wrote 11X equals C. All right. The second company charges a base fee. Remember, that is the y-intercept plus $7 per window. So it's $7 times the amount of windows that you get washed plus the base fee of $44. And this is your cost. And I just kind of wrote that reverse. Instead of C equals 7X plus 44, I wrote it reversed. So the question is, how many windows would you need to have for the second company, this one, to be preferable, or for the second company, this one, to cost less money, since this is cost? So what you're going to do is say, when will B, 7X plus 44, be less than 11X? For what value of X, basically, is what we're solving. So you could do a less than, or you could say equal, okay? So let's just do equal for now. And so this is going to tell us the number of windows where the cost would be equivalent. Okay. The same, it would cost the same. So let's solve for X. Let's subtract 7X from both sides. 44 is equal to 11X minus 7X is 4X. And then divide by 4. We get X is equal to 11. Oh, there's a lot of 11s in this problem. Okay. So when X is equal to 11, then the cost is exactly the same, no matter which one. So if you had more than 11, then it would be preferable, is how you do that. And they want you to put 11 right there. Okay. The last one, we sort of set this up. When hired at a new job selling jewelry, you're given two pay options. Option A is a base salary, remember y-intercept, with a commission of 7% of your sales. Your commission is dependent on how much you sell. It's dependent on X. X, in this case, is going to represent your dollar value in sales. All right. And so to represent your salary for option A, it's going to be, your salary is going to be your base fee, $15,000 plus 7%, but we want to convert that to decimal point, 0.07 by dividing by 100. And this is your salary. Option B, you get a bigger base pay, salary, of 2,300,000, plus a lesser commission, 0.02X. And so the question is, in order for option A to be, to produce a larger income, a bigger salary, you would need to sell more than how many dollars of jewelry each year? So they want you to say, how much do you have to sell in order to this one to be good? Because if you're not good at sales, obviously you would rather have a bigger base pay, not dependent on that. But if you're great at sales, how much do you have to sell? So this is what we need to know. $15,000 plus 0.07X is equal to $23,000 plus 0.02X. So since X represents the number, the dollar value of sales, this is going to tell you when the salaries are equal. So let's solve this. I'm going to get all my X's on the left, minus 0.02X, which is 0.05X. I'm going to get all my things without X's on the right. So I subtract 15,000. And when I do that, I get 8,000. And I divide by 0.05. And this is going to tell me that 160, when I sell $160,000 worth of jewelry, then I can't imagine myself doing that. I hardly wear jewelry. But if I sold, I would have to go with definitely the bigger base pay. But if you sold this much, then you're making the same salary. But if you sell less than this, it's better to go with option B. But if you sell more than this, it's better to go with option A. So this is what we put in there. All right. That's the end of this one.